Morning, YouTubers. I got a fun video for us today that I thought we could all learn something dealing with 60-10 and uphill and filling like gaps per se. So what I have here is a 1/4-inch plate set. There's no gap at the bottom and then a whole bunch at the top. I mean, so much that I would say it's pretty much 3/16 of an inch. I mean, this, if I pushed hard enough, would go through it. So this is an 1/8 inch rod plus a flux, definitely a big gap. One of the huge benefits of 60-10 is how fast that molten puddle quenches and freezes. That will give us the ability to weld this uphill despite having a big gap and allow us to control that deposition of metal per se. In layman's terms, we can cross and bridge the gap and step forward and bring it back, and we can stack metal on metal and make it all the way up. Now, no, this isn't gonna have perfect reinforcement on the back. This video isn't for that. I mean, that's why you run on thicker plate, you run bevels and controlled gaps and all of that, because it gives you consistent reinforcement on the backside. This is a great how-to if you're looking at fixing some scabby stuff on the farm or an emergency repair where you have a gap. Rather than running 70-18 uphill and likely having it drip and get too hot and just uncontrollable, grab yourself a 60-10 or even 60-11 if your welder won't run 60-10 and go to town with that. So let's get into it. So now that you're seeing what I'm seeing here, you can see this. So 1/8 inch rod, I mean, that's floating in there. And then it obviously tightens down to nothing. Not good at all. This is gonna be common on scabby material or some repair you might have to do. And you gotta think like, well, am I gonna make an absolute perfect weld on this? Well, it's gonna be pretty hard. I mean, that's the whole point of prepping your material properly. I mean, I did clean this just to help us a little bit, but beyond that, I mean, this gap, you know, uphill too is gonna be a bastard. I mean, I've done many of welds like this underneath a trailer with minimal visibility, and 70-18 is not the rod that I would want to be running doing this. You just don't have the control, especially uphill. Now, if you could move this and weld it in a flat position, the gravity will help pull the weld through it, but even in that case, you're probably still going to get drips with 70-18. And again, that's not the point of this. The point of this is that this is maybe a crack or some repair you have to do on what you're working on just to get out of Dodge, whatever it is. So we're gonna start down here and we're gonna weld all the way up. Now I am using 5P red rods. I am not using the 5P plus, or like Hobart and a lot of other brands just have unclassified 60-10. 5P freezes very fast. 5P plus and a bunch of the other rods, like if you watched my 60-10 intro video, I covered a lot of that. The puddle's more liquidy and won't help us as much. This is a great rod for doing repairs like this. So let me get the arc footage set up, or the camera, and then let's get this going. So I'm gonna start the arc footage halfway up the plate because the beginning part there was no gap, so that went real easy. But I'm starting about halfway up the plate here. If you notice, I'm letting the rod fill, and then I push the rod forward, let it fill, push it forward, let it fill. I'm letting it fill till I can see the puddle wets out to the sides of the groove there, or not really groove, but the side of the plates. So now I'm stepping forward a fair amount and bringing it back. The time that I'm out of the puddle solidifies, and then I can stack more metal on top of it. Now the gap is getting pretty big, so even that makes it difficult, but you can kind of see the technique that I'm using. All right, so let's take a look at what we got so far. And if I haven't mentioned it, don't worry about all this black stuff on my fingers. I was using spray foam earlier, and my God, should have worn gloves. Little bit went a long way. So down here, we're cold, as to be expected. I set the machine for the amperage necessary from about the 1/3 and up point, not down here, so we lack penetration. And that's something to be said. It's smarter to increase your amperage, run where it's tight to get that penetration, then lower your amperage to weld up where it's got a bigger gap. So everything from about here up to about like right here is looking real good. I think I had a tie-in right here if I remember right. Well, didn't wait long enough and left a little hint of undercut on the sides. Not really a huge deal. Let's go and look up here. Now got real rough at the top. What I should have done is I had a really good run up to about here. I should just pulled out, left it, let it cool. Once it's, you know, a good 5 minutes cool, restarted and then welded up to here. Anytime you hit the top where there's no place for the heat to go, you're gonna have issues with it blowing out. In this case, it blew out, it got a little bit of slag in there. It's fixable, but you can learn from my mistake there. It also would have helped if I had a much more solid tack up top, that it would have carried more of the heat. I had a pretty thin, weak tack up there, and well, guess what? It didn't offer me anything when it came to heat sink. Again, for 60-10 uphill, not looking too bad. The profile, you can tell, flattens out as it comes up. So that's partially because the weld is sinking into the plate due to the gap, and it's also partially because the weld itself was depositing hotter. You can see a more distinct ripple pattern here. It starts to smooth out a little bit here. Heat input affects and changes all that. So let's take a look at the back. As expected, virtually no penetration, probably not even an eighth into the plate where the gap is tight. Now this, due to the weld on the other side shrinking, actually pulled together quite a bit. If you remember, there was a gap here that was better than an eighth. You look here, it's like a 1/16. So don't be surprised if you run a wide gap and have to weld it, that it actually pulls shut, which brings up a very important point. Generally speaking, you don't want any gap. Now, if you need to do a full penetration weld on 2 plates or pipe or something, yeah, you run a gap to get the penetration. But depending on what you're welding, having a gap means that as that weld shrinks, things are going to get pulled. If you don't account for that pulling, you can end up warping things. Like I saw a guy stick weld a truss on an axle for an off-road vehicle, and when he was done, literally the axle tubes were bent in every which way because of how bad it pulled. Like, you don't want gaps in a lot of cases. So no penetration, hit this point, starting to get some penetration through, definitely have some here, here, as well as here. There's still some flux in there, so it looks rougher than it really is. And let's be honest, the backside of a 60-10 isn't gonna look that good anyways. So my thought is, well, there's a lot of things we could do from this point. If I only had access to this face of the 2 plates and I had to weld it with the gap that we had, this is about what you're gonna expect. I could have done a little better on the top, but it's, you know, it's gonna be a little bit tricky. Now, if I have access to the backside, I would do just like I did, run a pass, and then I'd grind this out a little bit to where it looks like clean metal, and then I would do a back pass on it. For the sake of training, I think we're actually gonna do that. So what I'm gonna do is I'm gonna grind this out to where I can see clean metal all the way up, and then I'm gonna run another pass on this side all the way up to give us, you know, decent reinforcement on both sides. Now to fix this, I'll also do that for training purposes. I'm gonna grind this area out clean and then start a rod here and then just weld it up in order to finish that out and have it looking a lot better. I'll also fix this undercut here, which I don't know if you have to be able to see that. A blind man could see that. I'm gonna grind that out a little bit and then just do a little weld on that, because you don't really wanna leave undercut that big either. This, like I said, looks overall pretty good, but yeah, I'll tack this to the table and I'll get to grinding, cleaning this up, and then we'll weld it and go to fixing the front side. So I ground a groove the whole length of the back to clean it out, to clean metal, and then I'm just gonna uphill weld it. You'll be able to see that groove as I'm welding it, and just pay attention to how I'm bringing it up. I do a slight oscillation left and right, like I'm talking almost you can't even see it, just to help push the metal a little bit. And I'm just making sure that the weld fills up enough to where it's tied in over the edge. Pretty simple. All right, so let's do an update. I ground a little concave line all the way up to about right here. It was looking pretty good. This all welded fairly decent, no real issues. Now when I got up to about right here, I ended up getting really bad arc blow. Snapped out of it, restarted. It sort of welded, but you can see this big glob, just a lot of spatter. Didn't weld that good, and I can tell you a couple reasons as to why, and that's material prep. This was all clean. Up here, I really didn't do much grinding on it. I was just gonna weld over it, you know, like a lot of people try and do, and guess what? Well, if the front side had something that looked like this and likely slag inclusion in it, and then that's all kind of sitting just on the other side of this face, well, if you weld over, what do you think's gonna happen? It's gonna weld poorly. So what I should have done is grind this plate flat, a little bit concave in there, clean that crap out, and then it would have welded just like this did without all of this. So I learned a valuable lesson here. Material prep really matters even with 6010 5P. So to fix this, what I'm gonna do is I'm just gonna grind it from about right here up flat, and then I'm gonna get in there with like a hard rock wheel and just clean this out a little bit in a V taper or U taper, and then just weld it all the way up to the edge. Then we're gonna flip it around and we're gonna fix the front of it. But you can see when you're gapping everything, I mean, there wasn't a gap, but there's a nice channel to weld in, and you take your time. I mean, this looks really good for uphill 6010. That's what you wanna be shooting for. But I'm gonna fix this. I'll shoot a picture of it after I fix it, and then we'll go from there. All right, so this looks a little cooked because we welded the other side and it grayed out and I haven't buffed it. So I ground this out pretty clean. You can see there's a little bit of evidence of maybe porosity or something in there. I could grind it a little bit more, but for the sake of what we're doing, I think it'll be just fine. I'm gonna start up here and I'm gonna weld this vertical down, I think. And the reason for that is this is thicker than this. If I start down here, my tie-in is gonna tend to be cold, and then it's gonna be too hot up here, and I'm gonna end up blowing through this edge again. So by starting vertical down, tying in left, right, and then bringing it down, I think I'll be able to get it, you know, hotter down here and tied in better. We'll see though, I could be wrong. Once I do that, I'm gonna come over here, grind this just a little bit to prep it, and I'm gonna use a smaller rod than this 1/8 to start down here and just weld uphill a little bit, just to kind of cap that and clean that off to where we don't have that undercut. Now obviously if this is something super critical, you don't want undercut. Realistically, if this is some scabby thing on a farm, who really cares? But you know, attention to detail does matter. You're better off cleaning it up and then welding over it to get rid of it than you are leaving it, honestly. But yeah, I'll just brush the rest of this flex off, slag, and we'll weld it up. All right, so a little bit change in the plans. I cleaned this up where this undercut was. I think what I'm gonna do is start down here, bring it up, and then tie it in and do one more pass. It was a little bit below flush. I mean, this is about what you want. This is okay, but if I start down here, bring it over, and fill it in for a last pass to clean it up. And again, I mean, if you're welding on some farm equipment, is this all really necessary? Nah, probably not. I'm just showing you how to fix stuff to make it better than what it is. So let's get the arc footage. So let's wrap this up. Now this was the second side where I just grounded a small V groove all the way to clean material and then welded it up. And you can see how much better and cleaner that welds when you have essentially a very consistent base material gap, or in this case a groove to weld to. When I restarted and ran this, I just ground down the end of it because I welded that downhill a little bit just to clean it up. But you can see when everything's consistent, pretty decent results. Now on this side, despite having a small gap opening up to a big gap, once we hit about right here, the gap became so excessive it was much more difficult to weld. So gap does matter, but I did weld it. Now I went back and repaired this, and you can see that even though I ran it, actually, yeah, I started down here, I believe, and then welded it up. You can see that my start was a little bit cold. I really should have welded that vertical down starting up here and then tied in when the puddle was really hot. On this thick a plate, I was at 85 amps, and that really wasn't enough to have a hot start. I mean, it's tied in there. It looks worse than it is in person. But, you know, grinding that down, cleaning that up, flattening out a little bit will go a long way. It's not a structural issue, especially for if you're welding this on your tractor or something, but it's just something to think of. The other thing is that there's a bit of porosity slag inclusion in the top, which is, again, very common because of how hot this gets. It's very difficult with 6010 at an end like this to fill it in the vertical up position. It just gets heat soaked so bad. But, you know, grind it down again and then retouch it up, grind it down. I mean, it all depends on how good you want to make it. Is it necessary? It all depends on what you're welding. But you can see if you maintain a reasonable gap, weld it uphill, you'll get really good results. When things get real wide, it's gonna be a struggle. There's no way around it. And then when everything's consistent, works great. Hopefully you learned something. I also learned, I want to show you something. So these are ESAB 5P red rods. I got a bunch of these for free with an ESAB welder I bought. If you look at it, I find it interesting. The amount of this that sticks out past the flux is extremely inconsistent with these. Now I run ESAB 7018 primes and have no issues. But these, I believe these are Sure Weld, which I don't even know where the other half of the package is. Here it is. These are available in little like 1 or 2 pound packages. and they're also available in like, yeah, this is a 1 pound package. They're available in bigger, like 10 pound, but I don't know, that's kind of annoying to me. Like, how are you gonna clamp your stinger on that? It's gonna bite the flux, and then you're gonna try and start it and wonder why it's not starting to arc. So anyways, they ran good. It's just, I don't like that. But yeah, there you have it. Hopefully, like I said, you learned something. If you got any comments, questions, leave them down in the comment box. Otherwise, thanks for sticking around for the whole video. See you guys around. Bye.